Hello everyone, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher, and today we are going to discuss about the another chapter from the another chapter from chemistry, and that is nothing but is matter around us pure. So let me first of all write down the title of this chapter. Okay, so this is the name of the chapter, and we are going to discuss a topic from this chapter for today, and the title of this topic is what is mixture. Okay, so in the previous class, if you remember guys, we have discussed about the matter in our surrounding. In that we have discussed about different types of the what you can say different properties of the matter, different states of matter, and in detail about their physical as well as chemical properties, right? Okay, so now in today's class we are going to discuss about the next chapter from this chemistry, and that is nothing but is matter around us pure. Okay, let me just give me a minute. Okay, yes, everything is fine. I have just checked that. So now if it is not, then please let me know in the chat box. You can anytime write down the message in your chat box, and I will be able to see that. Okay, so first of all, we are going to discuss about matter. Matter is nothing but the every different substance in the nature has different property, and depending on that properties, physical as well as chemical, the matters are classified into different types, right? Like solid, liquid, gaseous, plasma, and Bose-Einstein condensates. Okay, now in today's class we are going to discuss about is that matter pure, or if something is mixed with that matter, what will happen. So those things we are going to discuss in today's session. Okay, so for that purpose, to start with, first of all, I'll just tell you the classification of substances or matter into two main things, right? So matter means everything in the nature. So that matter is made up of two things. One is called as pure substances, and second is called as mixture. Pure substance will not have any other thing in it. It will be only pure substance, whereas mixture will have some additional things in it. Some impurities may be present in the mixture, right? So first of all, what is our first task? We are going to discuss the difference in between the pure substance and mixture in detail. Okay. Pure substances and mixtures. Okay, one by one we are going to discuss all the properties in detail. Okay, so first of all, about pure substances, they contain a single type of substance. Single type of substance. They contain single type of substance in them, whereas mixture contain more than two types of substances. Okay, second point of differentiation, they cannot be separated into other substances by physical methods, and mixtures can be separated by physical methods. Okay, then last point of differentiation in them, pure substances, they have their own definite properties. They have their own definite properties. Pure substances have their own definite properties, whereas mixtures show the properties of their components. Properties of their components. Okay, so these are the points of differentiation in between pure substances and mixture. You can just take a screenshot of this page first of all. Okay, now after this we are going to discuss, after the mixtures, classification of mixture into two types, into, that is, classification of matter into two types, we are going to see in detail about the mixtures. Okay, we are not going to discuss about the pure substances henceforth. Okay, yes, so I'll give you some examples of substances over here, and we are going to discuss these examples or these substances in detail. So first of all, it is what you can say, salt. Okay, the salt which we use in our day-to-day life. Okay, then another example, another substance is the oil. Okay, and then another example is pure milk. Okay, only milk, right? Okay, now here, if you have ever seen, the word pure is written in the bracket or in on this here also pure salt is written on the packet of these substances which we buy from the market, right? What does this pure substance, why they have written pure in it? For an example, if I am talking about this salt, so as we know, salt is isolated. Salt is produced in the sea, and it is isolated from the sea water by evaporation technique, right? Now apart from salt, that is apart from sodium chloride, right, salt is which we are consuming is sodium chloride. Apart from that sodium chloride, in sea water there are another types of salts also present, right, like magnesium chloride, potassium chloride. These salts are also present in the sea, but we don't consume them, we don't eat these other salts, right, we only eat sodium chloride, right. So therefore, what is the next task after isolation of the substances? We need to separate the other impurities, right. So the other substances which may be present in the sea salt are impurities. Okay, so impurities are not present in the pure substances. In the pure substances, never. Impurities are not present in the pure substances, always remember, right. Therefore this word pure is written on the packets when we buy the things from the market, right. Now, but what if the other substances are present in them? What if some impurities are present, or what if some desired substances also may be present in the mixture, right. And therefore we are going to discuss about the mixture today. The best example of mixture is the air. Okay, best example of mixture is the air, right. What is air? Air is a mixture of different gases. Air is a mixture of different gases. What type of gases are present in air? Like hydrogen gas, helium gas, neon, argon, then oxygen gas, nitrogen gas, then chlorine gas, then sulfur dioxide, nitrogen dioxide, carbon monoxide, carbon dioxide, etc. Okay, these are the gases present in the air. So air is not a single component, but it is the mixture of different gases. Therefore A is a mixture. Air is the best example for the mixture, right. Apart from air, some other examples are soil, right. Soil is also a mixture of so many things. So soil is also an example of what you can say mixture. There are n number of examples of mixtures. We are going to discuss them one by one, but before that we are going to discuss about the types of the substances. Okay, types of the mixtures. Okay, I'll write down that on the next page. We are going to discuss now about types of the mixtures. Mixtures are classified into two types. Homogeneous mixtures and heterogeneous mixture. These are the two main types of the mixtures. Okay, what are the meanings of these two? First of all, homogeneous mixtures. In homogeneous mixtures, whereas in case of heterogeneous mixture, they are not having uniformly distributed particles. Particle stands for constituent particles here, right? Okay, so these are the two definitions of homo as well as heterogeneous mixtures. Homogeneous mixtures are those in which the particles, constituent particles, are uniformly distributed throughout the mixture, whereas heterogeneous mixtures are those in which the constituent particles are not homogeneously or uniformly distributed throughout the mixture, right? Okay, now homogeneous mixtures are also called as solutions. These are also known as solutions. Okay, one example I will write down. Homogeneous mixture, aqueous solution of water soluble substances. Okay, and the example for the heterogeneous mixture also I will write down. Examples are soil, sand, seawater, etc. Okay, so these are the examples of heterogeneous mixture. Okay, now you guys can do one thing, you can just take a screenshot of this page. Okay, yes, I hope you have taken a screenshot. Now we are going to see this there are heterogeneous mixture first of all, and then we are going to discuss about the homogeneous mixture, right? Okay, so first of all let us see methods for purification of or the separation of components from the heterogeneous mixtures. Purification of constituent particles from heterogeneous mixtures. Okay, yes, so let us see one by one all these methods. There are a variety of methods available for purification of constituent particles from heterogeneous mixture. Heterogeneous mixture can be purified by the physical methods only. No chemical methods are required for it. First method I will write down, and that is nothing but the simple filtration. Second method I will write down decantation. Third method I'll write down hand picking. Fourth method sieving. Fifth method winnowing, etc. So out of which some of the methods you have already learned in your class, lower classes, like in the class 7th I guess you have already learned about winnowing, sieving, hand picking, etc., etc. Decantation and filtration is new to you, right? So you might have performed the filtration in your science laboratory also, but one simple example of filtration which we observe in day-to-day life is filtration of tea, right? What do we do in tea while making a tea? Tea is also a mixture of the heterogeneous substance or heterogeneous mixtures. I'll write down here tea, coffee, all these are the heterogeneous mixtures, right? Okay, so here what we do while we are making tea, we first of all we mix all the components like sugar, tea powder, milk, water, etc. into each other, and after this we are heating the solution, right? While we are heating the solution, sugar is water soluble, right? So sugar get dissolved in the water, but what about the other components? Other components are not soluble in water. For that purpose what we are going to do, we are going to boil it, we are going to extract all the things from it, and we are going to throw the undissolved substances away from the tea, right? For that purpose we are going to do the sieving, right? Okay, so this is how these are the methods of separation, purification of the constituent particles, or instead of purification you can say the separation as well, right? So I am going to explain you about the filtration and decantation to you in today's class. Filtration, right? Okay, now this method we have performed in home n number of times. It's very simple experiment. I'll try to draw. Okay, so what you are going to do, simply you are going to take a paper like this. Okay, this paper is called as filter paper. Okay, a circle shaped paper we are going to take. We are going to simply cut it. Okay, we are going to simply not cut it, we are going to fold it. After folding what we will get? We will get folded filter paper, right? So this is a folded filter paper. Folded filter paper, right? Okay, now that folded paper we are going to make a cone out of it, right? We are going to make a cone out of that filter paper like this. Cone made from the filter paper, right? Now that cone made from the filter paper we are going to use for the filtration, right? Okay, for that purpose what we are going to do, we are going to take a funnel. Inside that funnel we are going to put a paper. Okay, and below that funnel we are going to take a container. Okay, yes, so this is the setup for the filtration. Now what we are going to do, we are simply going to take the mixture inside this funnel. We are simply going to pour the mixture from this direction. Now what will happen, as we are pouring the mixture over this funnel, whatever the soluble substances are there, like sugar, in case of milk it is sugar, or milk also, so whatever soluble things are there, those will go down through this solution, right? So this is how we are going to add the heterogeneous mixture. So this whatever this is how we are getting the droplets coming out from this, and it will be collected here like this. Okay, now in this case there are few things related to this filtration, like this is called as filter paper, then this is called as heterogeneous mixture, and whatever liquid we are getting is called as hetero, is called as the filtrate. It's called as filtrate. Filtrate, right? Okay, and whatever it is, it will be left on the filter paper. That will be called as residue. It's called as residue, right? So this is how we are going to separate the components of the heterogeneous mixture by simple filtration technique. Okay, so take a screenshot of this page first of all. Take a screenshot of this page. Okay, I hope you have taken a screenshot. Now we are going to see the next method for the separation of components, and second method it is, that is the decantation. Okay, what is it? First of all, we are going to add the mixture in the container. Like this. In which we are going to add the heterogeneous mixture. Okay, it contains these particles, right? Okay, this is the level. Like this. Now what we are going to do in decantation method, we are going to keep it for a long period of time, like for 10 hours, 15 hours, 24 hours, etc. Whatever the salt is produced, whatever the dust is produced, that will slowly go down, and it will accumulate at the bottom of the vessel. It will accumulate at the bottom of the vessel, and then what we are going to do, yes, after accumulation it will look like this. Initially all the particles will be displayed, and after it will look like this. Okay, it will be settled at the bottom. Now what we are going to do, after it is, once it is settled at the bottom, we are simply going to decant, or we are simply going to only remove the upper water layer very slowly. When we are going to remove the upper water layer slowly, very slowly, we can collect it in the another vessel, that will be the filtrate, and whatever residue is at the water. So this is the bottoms. This is called as a decantation technique, right? Okay, so by using these two techniques we are able to separate the mixture, which we are going to separate, remember, by separation of heterogeneous mixtures, right? For homogeneous mixture, physical properties will not work that much. For homogeneous solution or homogeneous mixtures, we need to perform some chemical experiments on them, and therefore we are going to try the separation of particles by these two techniques or the other techniques also for the heterogeneous mixtures, right? Okay, now in the next class what we are going to do, before that let us have a small recap of whatever we have learned today. So today we have learnt about the mixtures, right? Okay, so as we know, matter is divided into two parts, the pure substances and maternal or mixture, right? Pure substances and mixtures. In case of pure substances, they contain single type of the substances or constituent particles, whereas mixture contain more than two types of the substances or constituent particles. Pure substances cannot be separated by physical techniques. Mixtures can be separated. Pure substances have their own physical or definite chemical properties, whereas the properties of mixture are not its own properties. These are the combination of properties of all the components present in it. Now we have seen some examples for the mixture as well as for the pure substances, right? And then we have seen the types of the mixtures. There are two types of the mixture. One is called as the heterogeneous type, one is called as the homogeneous type, another is called as the heterogeneous type. Homogeneous stands for homogeneous mixtures are having uniformly distributed constituent particles, whereas heterogeneous mixtures have do not have uniformly distributed heterogeneous part. Okay, and last point of differentiation, these are also known, homogeneous mixtures are also called as solutions, right? Some examples we have seen. So some examples are for homogeneous mixture, any type of aqueous solution in water with this one, any type of solution, aqueous solution means in water which contains water soluble substances, right? Substances should be water soluble. If they are not, they will that will be the heterogeneous mixture. Whereas for heterogeneous mixture, the examples are the soil, the sand, seawater, tea, ink, then colored plant pigments, etc. Now after this we have discussed about how we can separate the components of the heterogeneous mixture, right? We have seen how we can separate or isolate components of heterogeneous mixture. There are varieties of ways available for which the winnowing, hand picking, sieving, etc. These methods you have discussed in your lower classes. In class 9th you are going to discuss about how the simple filtration is done and what is the decantation technique. So simple filtration is nothing but we are going to simply pour it on the funnel, and the funnel contains a filter paper, and simply it will come down of the funnel, converted into the filtrate, and whatever left on the paper is called as the residue. Okay. And in this case what happens is the residue which we are getting here, right? Sometimes what happens, guys, I'll give you simple example here. When I'm drinking tea, like, or when I prepare tea, at that time I filter the tea, right? Whatever I am getting in the form of a residue, that I consume. But whatever I am getting in the form of a filtrate I consume, but not the residue, right? That is in case of the tea. But on the contrary, another example I will give you. For example, I want to prepare the what you can say, the curd, right? I am preparing the curd by using the milk, by adding seed to it, right? What happens here? I get a curd and little amount of water also in it. So what I do, I filter it. Water I throw it away, and I consume the curd which is above, or which is in the form of a residue. So that is why for such a type of heterogeneous mixtures we are going to use the method called as a simple filtration, like this. Now here just one thing I forgot to tell you, like in case of some substances, like in which the what you can say, the substances contain very fine particles, those fine particles will very easily pass through the simple filter paper. But for those such a type of substances, we are going to use a special type of filter paper which is called as Wattmann filter paper, Okay, Wattmann filter paper means what? It is a special type of filter paper which has very small pore size, pore means hole, which has very small pore size. Due to that very small pore size, even very fine particle is there, it will not be able to come down, it will be there on the filter paper only, right? So this was about filtration and decantation. Decantation also you have learnt in the previous class. So that's it. Now that was about the mixtures. In next lecture, in tomorrow's lecture, we are going to discuss about the homogeneous mixture. Today we discuss about the heterogeneous mixture. In tomorrow's class we will discuss the homogeneous mixture. I have told you already, homogeneous mixture is nothing but the solution, right, whose components cannot be separated by using the physical techniques. Okay, that's all for today. If you have any doubt, please let me know in the chat box, and we are going to see the daily practice problems also in the portal in the form of PDF file later on. And let me just show you how to upload those daily practice problems. Just give me a second. I hope you are able to see. Just give me a second. Yes, so I hope you are able to see this. So on this, what you can do, whenever you want to, this is the teachers portal, whatever you can see over here, and when you go to resources, which is here, in resources you have to go left hand side, scroll down to the writing material. In the writing material you can see all these things: subject chemistry, chapter name, then date, and then classification, then due date before which you are going to submit the assignment. Here it will be in the form of PDF file. You will be able to download that PDF file, and you will see the question there. You can write down the answers on the notebook or on a blank paper, and you can submit it before the said date, right? I will evaluate them and I will let you know about suggestions and corrections in the solutions. Okay, so this is all about the DPPs. So today we will stop here. In tomorrow's class we will discuss about the next topic, that is solution. What is solution from the same chapter. Okay, thank you so much guys for your precious time, and all the best to you. Take care. Bye bye.